So today's lesson is about temperature. Temperature, I want you to think of temperature in terms of motion of molecules. So here I have a sample of water. Just looking at this, what state of matter would you think that water is in this picture? Now let me cool it a little bit and see if you can tell any difference. Okay, that's what state is it in now? Begin to heat it. See melting take place. Oh, I just gave it away. And as we continue to heat and the temperature is rising, you can see that the molecules separate from each other and turn into the gas phase. So the primary thing that I want you to know from this little animation is that as you increase the temperature, the molecules begin to move faster. Now right now, I've raised the temperature to 450 Kelvin, which is 177 on the Celsius scale, which is more than the boiling point. Now if I cool it, what's going to happen to the molecules? They're going to slow down, and you'll be able to see them start to slow shortly. So now we're cooling down. We're in a temperature that should create a liquid water, 36 degrees Celsius. That's about body temperature, the same temperature as your body. And if I lower it on down to 0, oops, went past it, I should see a mixture of liquid and solid. We're almost moving to the solid phase. Now if I keep getting it colder, like in your freezer, below 0, you can see a solid form. Just a little aside, did you notice this is water, and water separates a little bit when it becomes a solid? See these spaces between the molecules? That's why ice is less dense than water, and ice will float on water. That's unique to water. So water is a very special substance because it gets less dense when it's in the solid phase. All right, so let's talk about some scales. There are 3 temperature scales that we use, and I'm going to write down here before I write the scales that temperature is average kinetic energy. So what that means is that molecules, the kinetic energy is energy of motion, and so the average motion of molecules is what we define as temperature. You may remember from physics, the kinetic energy is 1/2 mass times velocity squared. But we won't need to know that for this little lesson. All right, so there are 3 temperature scales. On this particular temperature scale, it's the one you're most familiar with probably. I'm putting a couple of temperatures on. That's a 212. So 212 and 32. Do you know what those mean? This is the freezing point, and this is the boiling point. I might also mention that freezing and melting occur at the same temperature. Okay, so this is the Fahrenheit scale. That's the one that we use the most in our everyday lives, Fahrenheit scale. But in chemistry, we often will use the Celsius scale. And on the Celsius scale, the temperature of freezing is 0, and the temperature of boiling is 100. Then this brings us to a third scale. It's called the Kelvin scale. The Kelvin scale you're probably not familiar with. Those are the freezing points and boiling points, 373 for boiling and 273 for freezing. But what makes the Kelvin scale different is that it is based on 0 being absolute, and you can't go any lower than 0. So on the Celsius scale, you can go down below 0. On the Fahrenheit scale, you can go below 0. But on the Kelvin scale, you can go down to 0, but you can't go below it. So I'm going to put 0 here. I'll put a little couple hash marks here to show that I left out some line, because this is from here to here is 273 degrees, and from here to here is 100 degrees, so they're not the same. This little symbol means you left out some space. All right, so this is as cold as you can ever get, and that's called absolute 0. And we've never quite attained that temperature, but we've gotten very, 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 very close. Now, what does absolute 0 mean then? Remember, we're talking about molecules in motion. So, for temperature, so what if there was no motion? I'm not sure if this little animation is going to let me get down to absolute 0, but absolute 0 be negative 273.15, and we can't quite attain that. So you can see I'm not quite able to stop the motion. Oh, there it is, negative 273. And even we just can't get quite down to where there's absolutely no molecular motion. But if we could, theoretically, there would be 0 motion, and you can't get any colder because temperature is based on kinetic energy. Remember, temperature is based on kinetic energy. And if there is no kinetic energy, is energy of motion. If there is no motion, then you're down to absolute 0. You can't get any colder. All right, this is a part of a unit on gas laws. So when we're going to be doing some math in another lesson. So when you're dealing with gas laws, you can't use a temperature scale that has negative numbers on it. So what we have to use for gas laws, for gas problems, you have to always use Kelvin temperatures. Well, what that means is that we're going to have to change our Celsius temperatures to Kelvin. Now, I could show you how to do a conversion from Fahrenheit to Celsius, but if you want to know that, email me, because it'll take too long on a video to do that. But here's how you do the Kelvin and Celsius back and forths. So you notice that the distance between here and here is 100 degrees. And the difference between here and here is 100 degrees. So that means that the spacing on the scale is the same number of degrees. So from here to here would be the same number of degrees as from there to there. That makes it very simple to convert from Celsius to Kelvin. The Kelvin temperature is equal to the Celsius temperature plus 273. So if you have 0 degrees Celsius and you add 273, you get 273 Kelvin. If you have 100 degrees Celsius and you add 273, you get 373 Kelvin. If you have 25 degrees, it becomes 298. So if that was 25, then that would be 298 for the actual temperature. All right, so it's a very easy conversion. If you want to go the other way, the Celsius is going to equal to the Kelvin minus 273. But most commonly, we'll use that conversion. Just a quick note on on the Fahrenheit to Celsius, if you're curious about that, that's 180. At some point, the difference between freezing and boiling is 180. At some point in your previous education, you may have been taught a formula that included 5/9 and 9/5. So 180 over 100 reduces down to 9 over 5, and that's where that part of that formula originated. All right, so what we said, temperature is kinetic energy, energy of motion. There are 3 different temperature scales. The one that we have to use in gas laws is the Kelvin temperature scale. To convert from Celsius to Kelvin, you'll add the 273 to the Celsius temperature, and that will give you the Kelvin temperature. So that'll be the end of this little video, and we'll have another one on math in short order.